I've spent my life fascinated by the fundamental laws that govern the universe. From the tiniest subatomic particles that vibrate in ways our senses cannot perceive, to the vast expanses of space where galaxies drift in silent harmony. As a theoretical physicist and professor of theoretical physics at the City College of New York, I've devoted decades to trying to understand the hidden structures of reality. And I have found that the universe is far more intricate and astonishing than most people can imagine. Today, I want to take you on a journey that goes beyond the 3 dimensions we experience daily. Beyond the familiar up-down, left-right, forward-backward, and even beyond the ticking of time itself. This journey is into hyperspace, a domain where space can bend, time can twist, and entire universes may coexist alongside our own. It is a realm where the laws of physics reveal themselves not as static rules but as a dynamic, evolving tapestry, a multi-dimensional symphony that underpins everything from the motion of electrons to the dance of galaxies. In order to appreciate hyperspace, we must first consider the concept of dimensions. We live in a world that is 3-dimensional, length, width, and height, and we experience time as a 4th dimension, which allows us to measure the progression of events. Yet modern physics, particularly string theory, proposes that there are additional dimensions that are curled up so tightly that they are imperceptible to our senses. Imagine a garden hose. From a distance, it appears to be a 1-dimensional line. However, as you approach it, you notice its circular cross-section, revealing a 2nd dimension that was invisible from afar. The extra dimensions hypothesized by string theory work in a similar way. Compacted at scales far smaller than atoms, imperceptible yet profoundly influencing the universe's structure. These hidden dimensions offer explanations for some of the deepest mysteries in physics, including why gravity is so weak compared to the electromagnetic and nuclear forces, how black holes store information, and why the constants of nature appear so finely tuned to allow life. As we contemplate higher dimensions, it becomes possible to imagine realities that are simultaneously different and intimately connected to our own. Consider the concept of the multiverse, a term that has gained popularity not only in theoretical physics, but also in the imagination of the public through science fiction. The multiverse suggests that our universe may be only one of countless others, each with its own distinct laws of physics, initial conditions, and histories. In some of these universes, life as we know it might flourish, while in others, stars may never ignite, and galaxies may never form. Quantum mechanics provides a mathematical basis for the multiverse through the notion that every quantum event can spawn multiple outcomes, each realized in a separate universe. This idea challenges our intuition, but is a natural consequence of the equations that govern microscopic phenomena. If we follow this line of thought, one begins to see that every choice, every event, every fluctuation in the quantum foam could correspond to a branching reality, a universe slightly different from our own. It is a humbling perspective, one that forces us to recognize that the cosmos is vastly more diverse and expansive than our daily experiences suggest. Time, too, is not absolute. Einstein's theory of relativity taught us that time can dilate and contract, depending on velocity and gravitational fields. Clocks near massive objects tick more slowly, and light traveling across the cosmos is stretched by the curvature of space. In hyperspace, the implications are even more profound. Time may loop, warp, or connect distant regions of space in ways that our everyday intuition cannot grasp. Wormholes, hypothetical tunnels through space-time, could in principle allow travel between these distant regions, linking not just points in space, but potentially points in time and other universes. While the practical construction of a wormhole remains beyond our current technological capabilities, the equations of general relativity suggest that they are not impossible, provided certain conditions, such as exotic matter with negative energy density, could be realized. This possibility, while speculative, has profound implications for our understanding of causality, travel, and the nature of reality itself. To grasp hyperspace, one must also consider the underlying fabric of reality, as described by string theory. Instead of point-like particles, string theory proposes that the fundamental constituents of matter are one-dimensional strings that vibrate at different frequencies. These vibrations determine the properties of particles, from mass to charge, and by extension, the structure of the universe. Strings require additional dimensions to be mathematically consistent, and it is in these hidden dimensions that the universe may find its most elegant and profound explanations. Beyond the theoretical mathematics, hyperspace has practical consequences for our understanding of phenomena, such as black holes. Black holes, regions of space where gravity is so intense that nothing can escape, are often considered endpoints of matter and energy, yet they may also be gateways to higher dimensional spaces. The information paradox, which asks how information can escape or be preserved when matter falls into a black hole, may find resolution when higher dimensional effects are considered. It is conceivable that information is not destroyed, but encoded in dimensions beyond our perception, awaiting discovery through the language of advanced physics. As we move from the infinitesimal to the cosmic, hyperspace also informs our understanding of the early universe. The conditions at the moment of the Big Bang, where all matter and energy were compressed into an extraordinarily dense state, may have been influenced by higher dimensional geometry. The inflationary period, during which the universe expanded at an exponential rate, could be a reflection of hidden dimensions dynamically shaping the growth of space and time. In contemplating these vast ideas, one begins to appreciate the interconnectedness of the microcosm and the macrocosm. The tiny vibrations of strings dictate the formation of atoms, which in turn form stars, planets, and galaxies. The same principles that govern subatomic particles influence the trajectories of celestial bodies, the curvature of space, and the evolution of the universe itself. Hyperspace thus provides a framework that unites seemingly disparate phenomena under a single theoretical umbrella. It is also important to consider the philosophical implications. If parallel universes exist, then notions of destiny, choice, and uniqueness take on entirely new meanings. Every decision could spawn a new universe, every action may reverberate across a multiverse, and the concept of self may be far more complex than our limited perception suggests. Consciousness itself may interact with these dimensions in ways we have yet to understand. And future research in neuroscience and quantum physics may illuminate how the mind interfaces with the broader structure of reality. The exploration of hyperspace is not merely academic. It inspires new technologies and new ways of thinking about problems. Quantum computing, space travel, and the search for extraterrestrial life are all informed by our understanding of higher dimensions. Even artificial intelligence, by modeling complex systems, may reveal hidden patterns that point to the structure of the universe in ways humans alone cannot perceive. As we reflect on these ideas, it is natural to wonder how they relate to the science fiction that populates our culture. Concepts such as warp drives, time travel, and alternate realities are often seen as the province of imagination, yet they have firm grounding in the mathematics of hyperspace. Science fiction acts as a bridge, encouraging the public to envision possibilities that physics may one day make real, and motivating scientists to turn theory into experiment. In contemplating the vastness of hyperspace, one also confronts the question of scale. The universe is incomprehensibly large, yet the structures within it are delicately balanced. Stars burn for billions of years, galaxies rotate in perfect harmony, and planets orbit in stable configurations. Hidden dimensions may govern these balances, enforcing stability through laws that operate beyond our immediate observation. The more we study the universe, the more we realize that what we see is only a shadow of a far richer reality. A reality where dimensions interweave, where multiple universes coexist, and where time and space are flexible rather than fixed. In this sense, hyperspace is not a distant abstraction, but a framework for understanding everything from the subatomic to the cosmic scale. Every particle, every photon, every quanta of energy participates in this multidimensional dance, shaping a universe that is simultaneously elegant, complex, and beautiful. And as we probe deeper, our understanding evolves, challenging our assumptions and inviting us to rethink the nature of existence itself. As we move further into the implications of hyperspace, we must consider not only the theoretical elegance of extra dimensions and parallel universes, but also the profound philosophical and scientific consequences they entail. For if our universe is but one of countless others, each potentially obeying slightly different laws of physics, then the notion of uniqueness is called into question. And what we once regarded as the constants of nature may be merely one realization among an infinite spectrum of possibilities. And this reframing of reality forces us to reconsider the nature of causality, choice, and the very essence of existence. For in a multiverse where every quantum event spawns new realities, every decision we make could resonate across countless worlds. And even the concept of self may be far more complex than our everyday perception allows. For we are not merely isolated observers, but participants in a vast, branching web of realities, and this realization is both humbling and exhilarating. For it suggests that the cosmos is far more intricate than any human mind can fully comprehend. And yet the pursuit of understanding is a pursuit of profound beauty, of a universe where mathematics, physics, and imagination converge. And as we contemplate these extraordinary ideas, we must also confront the nature of time, which in hyperspace is no longer a linear, immutable river, but a flexible dimension subject to curvature, distortion, and the influence of massive gravitational fields. And time can stretch, compress, or loop back upon itself in ways that defy our intuitive understanding. And the concept of wormholes emerges naturally from this framework. These hypothetical tunnels through space-time that could connect distant points in space, or even different universes instantaneously, offering the tantalizing possibility of journeys that defy conventional constraints. And while the creation of traversable wormholes remains beyond our current technology, the equations of general relativity demonstrate that they are physically consistent under certain exotic conditions, particularly the presence of negative energy, and this illustrates a broader principle. The universe is not constrained by what seems possible within our everyday experience, but instead operates according to deeper mathematical truths that we are only beginning to uncover. And in this exploration, string theory provides a profound and unifying perspective, suggesting that all matter is composed of one-dimensional strings whose vibrations determine the properties of particles. And these strings exist within the higher dimensional fabric of the cosmos, giving rise not only to particles and forces, but also to the very geometry of space itself. And by studying these strings, we begin to see the interconnection between the microcosm of particles and the macrocosm of galaxies. For the same underlying principles govern both realms, revealing a universe of astonishing coherence, symmetry, and elegance. And when we turn our attention to black holes, these extreme objects provide laboratories for understanding hyperspace in practice. For within the event horizon, the curvature of space-time becomes immense, and the interactions of matter, energy, and hidden dimensions are laid bare. And phenomena such as the information paradox challenge our understanding of how information is preserved, and suggest that extra dimensions may encode and safeguard the data of the universe in ways invisible to our three-dimensional perspective. And as we consider the early universe, the Big Bang, and the inflationary expansion that followed, hyperspace offers insight into how these cosmic processes unfolded, how matter and energy were distributed, and how the structures of galaxies, clusters, and superclusters came to exist in such remarkable harmony. And every particle, every photon, every fluctuation of energy participates in this multidimensional dance, reflecting the intricate geometry of the hidden dimensions that form the substrate of reality. And the more we study the cosmos through the lens of hyperspace, the more we realize that imagination and mathematics are intimately linked. For the theoretical constructs of higher dimensions, string vibrations, and parallel universes are not mere flights of fancy, but rigorously derived consequences of the equations that govern the physical world. And in contemplating these ideas, we gain a new perspective on the relationship between science and philosophy. For the search for understanding is both a quest to explain the observable and a journey to grasp the extraordinary, hidden truths that lie beyond. And as we integrate these insights, we begin to see that the universe is not only a physical entity, but a framework in which consciousness, observation, and reality intersect, suggesting that our role as observers may be fundamentally intertwined with the multidimensional structure of existence. And this understanding has far-reaching implications, influencing everything from quantum mechanics to cosmology, from the behavior of black holes to the evolution of galaxies. And as we explore hyperspace further, we are confronted by the idea that the universe is at once more expansive, more intricate, and more wondrous than we can intuitively comprehend. And yet, through mathematics, imagination, and persistent inquiry, we gradually peel back the layers of mystery, uncovering a reality that is both beautiful and profound. And as we contemplate the hidden dimensions, the multiverse, and the intricate dance of strings and space-time, we recognize that the pursuit of understanding is not simply an academic endeavor, but a human journey, a striving to see beyond the limits of perception, to grasp the vast and mysterious architecture of the cosmos, and to appreciate that existence itself is far richer, stranger, and more elegant than we have ever imagined. And this journey through hyperspace is an invitation to expand our minds, challenge our assumptions, and explore the extraordinary possibilities that lie hidden in the fabric of reality. A journey that merges physics, philosophy, and imagination into a single, continuous quest for truth, understanding, and awe. As we continue to explore the astonishing implications of hyperspace, it becomes clear that the study of higher dimensions is not merely a theoretical exercise confined to blackboards and equations, but a profound journey that challenges the very foundations of how we understand reality. For when we consider the intricate interplay of space, time, and hidden dimensions, we see that what we perceive with our senses, three-dimensional objects moving through a linear progression of time, is only a projection of a far more complex, multidimensional reality. And it is within this broader framework that we begin to comprehend phenomena that have long puzzled scientists. From the weakness of gravity compared to other fundamental forces, to the precise tuning of constants that allow life to emerge. And as we contemplate the multiverse, we are forced to confront the possibility that countless versions of reality coexist simultaneously, each reflecting different outcomes, histories, and physical laws, so that every decision, every fluctuation of energy, every quantum event may give rise to alternate worlds, some nearly identical to our own, others wildly divergent. And in this vast landscape, the familiar concept of causality becomes more nuanced, for events may unfold differently across multiple universes, yet remain connected through the underlying geometry of hyperspace. And as we ponder time, we realize that it is not a fixed, absolute backdrop, but a dynamic dimension influenced by gravity, velocity, and the curvature of space. So that clocks move at different rates depending on their position and motion. And the possibility of wormholes emerges naturally from this understanding, as structures within space-time that could connect distant regions, or even different universes, instantaneously, offering the tantalizing possibility of travel that defies conventional constraints. And while practical traversal of wormholes remains beyond our current technology, the mathematics demonstrates that such constructs are consistent with the laws of physics if certain exotic conditions, such as negative energy, are present. And this reveals a broader principle, that the universe is not limited by our everyday intuitions, but instead operates according to deeper, elegant mathematical laws that govern not only what we see, but also the hidden dimensions that shape the universe. And as we turn to string theory, we find a framework that unifies matter, forces, and the geometry of space itself, suggesting that all particles are manifestations of one-dimensional strings vibrating in higher dimensional space, with each vibration corresponding to the properties of matter, energy, and the fundamental interactions. And these strings require extra dimensions for mathematical consistency, implying that the universe is far more intricate and multidimensional than our daily experience allows. And when we examine black holes, these extreme objects provide natural laboratories for understanding the principles of hyperspace. For within their event horizons, space-time is intensely curved, matter is compressed to extraordinary densities, and the interactions of strings and hidden dimensions are revealed in extreme conditions. And even the information paradox, which questions how information behaves when consumed by a black hole, may find resolution when considered in the context of extra dimensions, suggesting that the universe has mechanisms to preserve information beyond the three dimensions we perceive. And as we look back to the early universe, the Big Bang and the inflationary expansion become phenomena not only of immense scale, but also of remarkable order, shaped by the underlying geometry of hidden dimensions, which influence the distribution of matter, the formation of galaxies, and the large-scale structure of the cosmos. And every particle, every photon, every quantum fluctuation participates in this grand cosmic dance, reflecting the multidimensional structure that forms the substrate of reality. And as we ponder these extraordinary possibilities, we see that imagination, mathematics, and observation converge, for theoretical, Constructs such as higher dimensions, parallel universes, and wormholes are not merely abstract speculations, but consequences, rigorously derived from equations that describe our universe. And in contemplating these concepts, we are invited to explore not only the physical universe, but also the philosophical implications. For if infinite realities coexist, notions of destiny, choice, and individuality take on entirely new meanings, and consciousness itself may interact with these dimensions in ways we are only beginning to understand, suggesting that our role as observers is intertwined with the very fabric of existence. And this perspective has profound implications for everything from quantum mechanics to cosmology, from black holes to galaxy formation, from the origins of matter to the ultimate fate of the universe. And as we continue to explore hyperspace, we are reminded that the cosmos is not merely a stage on which life unfolds, but a dynamic, multidimensional entity in which every element participates in a continuous, elegant, and intricate dance. And as we peel back the layers of mystery, guided by mathematics, imagination, and observation, we uncover truths that are both beautiful and humbling, revealing a reality far stranger, richer, and more elegant than our senses alone could ever perceive. And it is in this pursuit of understanding, this journey through the hidden dimensions, that we encounter the profound awe and wonder of existence, realizing that reality is far vaster, more intricate, and more interconnected than we have ever imagined. And through this lens, the study of hyperspace becomes not only a scientific endeavor, but a celebration of the universe's elegance, complexity, and infinite possibilities, a journey that invites us to expand our minds, challenge our assumptions, and explore the extraordinary dimensions that lie beyond the familiar. All the while recognizing that every particle, every wave, and every quanta of energy participates in this grand, multidimensional cosmic symphony that is the universe itself. As we continue our exploration of hyperspace, it becomes increasingly clear that the universe is not simply a collection of particles and forces arranged in three-dimensional space, but a profoundly interconnected multidimensional system in which every element interacts with every other element, through hidden structures and forces that we are only beginning to comprehend. And as we consider the implications of these higher dimensions, we realize that the very fabric of reality is more flexible and dynamic than our senses suggest, for space can bend, twist, and connect in ways that defy ordinary intuition, and time itself, far from being an immutable linear progression, can dilate, loop, and branch, depending on the geometry of space-time, the presence of mass, and the influence of gravity. And when we apply these principles to phenomena, such as black holes, we find that their extreme gravitational environments offer a window into hyperspace, revealing interactions between matter, energy, and hidden dimensions that challenge our understanding of physics and the limits of observation. And while the information paradox has long puzzled scientists, suggesting that information could be destroyed when matter falls into a black hole, hyperspace and string theory provide potential solutions, positing that information may be preserved in higher dimensions, encoded in ways that are invisible within our three-dimensional perspective. And as we reflect on the early universe, the moment of the Big Bang and the subsequent inflationary expansion illustrate the influence of hidden dimensions on the large-scale structure of the cosmos, shaping the distribution of galaxies, clusters and voids, and ensuring the delicate balance required for life to emerge. And as we examine the microcosm, the vibrations of strings, the behavior of quantum particles, and the interactions of fundamental forces reveal a consistent pattern, showing that the same principles governing the tiniest components of matter also influence the largest structures in the universe, and this unification provides a framework for understanding reality as an elegant multidimensional tapestry in which every particle, wave, and photon participates in a cosmic dance that transcends our limited perception. And when we consider parallel universes, we confront the staggering possibility that every quantum event, every decision, and every fluctuation of energy may give rise to a separate reality, creating an infinite branching of worlds, some almost identical to our own, others radically different, each governed by mathematical principles that ensure internal consistency, yet varying in structure, history, and outcome. And in this context, our understanding of causality, identity, and consciousness must be expanded, for we are not isolated observers, but participants in a multiversal web, our choices echoing across multiple realities, and time, as we know it, becomes an emergent property rather than an absolute, flexible and dependent on the geometry and curvature of space. And wormholes emerge as natural constructs in this framework. Hypothetical tunnels that could connect distant regions of space or even different universes, potentially allowing instantaneous travel across vast distances or even across alternate realities. And although constructing a traversable wormhole remains beyond current technology, the mathematics validates their possibility, contingent on exotic matter with negative energy. And this illustrates a deeper truth. The universe is not limited by our sensory experience but operates according to elegant mathematical laws that manifest in ways we are only beginning to perceive. And string theory further reveals that the fundamental constituents of matter are one-dimensional strings, whose vibrations encode every property of particles, from mass to charge. And these strings exist within the hidden dimensions of hyperspace, giving rise to matter, energy, and the very geometry of space itself. And when we consider consciousness, the human mind, and the role of observers, we see that hyperspace suggests a profound connection between perception, information, and reality, indicating that understanding the universe requires not only observation, but imagination, mathematics, and curiosity. And as we explore black holes, cosmic inflation, multiverses, and higher dimensions, we recognize that hyperspace is not an abstract fantasy, but a framework that unifies the microcosm and macrocosm, revealing patterns and principles that govern all scales of reality, from subatomic particles to galactic superclusters. And as we journey through these ideas, we are reminded that the pursuit of knowledge is not merely academic, but a human quest, a striving to comprehend the extraordinary complexity, elegance, and interconnectedness of existence. And it is through this continuous exploration that we gain a glimpse of the hidden truths of the cosmos, discovering that reality is far stranger, more intricate, and more magnificent than our everyday experience can suggest. And as we push the boundaries of science, imagination, and understanding, hyperspace becomes not only a subject of study, but an invitation to expand our minds, challenge assumptions, and contemplate the profound possibilities that lie just beyond the familiar dimensions of perception. A journey that merges physics, philosophy, and wonder into a continuous, uninterrupted vision of the universe, in which every particle, every string, every fluctuation of energy participates in a grand multidimensional symphony that is the cosmos itself. As we dive ever deeper into the nature of hyperspace, it becomes increasingly evident that the universe is not simply a three-dimensional arena in which matter exists and events unfold, but rather a profoundly interconnected multidimensional structure in which every particle, every wave, every fluctuation of energy participates in an intricate cosmic choreography. And when we consider the hidden dimensions predicted by string theory, we begin to understand that these extra dimensions, curled up at scales far smaller than atoms, are not merely mathematical curiosities, but essential elements that determine the behavior of matter, the propagation of forces, and the very stability of the cosmos. And as we extend our gaze to parallel universes, we are confronted with a staggering vision: countless realities existing simultaneously, each with its own unique laws, initial conditions, and histories, where every quantum possibility is realized somewhere. And in this vast multiverse, the consequences of events, decisions, and fluctuations extend far beyond the familiar three-dimensional framework. And time, no longer absolute, becomes a flexible dimension, influenced by the curvature of space, the presence of mass and energy, and the dynamics of hidden dimensions. And in this context, wormholes emerge as natural constructs, tunnels that could, in principle, connect distant regions of space or even entirely separate universes, potentially enabling travel across distances or realities that would otherwise be inconceivable. And while traversable wormholes remain a theoretical challenge, their mathematical consistency underscores a broader principle. The universe operates according to deeper laws that may be counterintuitive, yet are precise, elegant, and consistent across scales. And as we explore string theory further, we realize that the fundamental constituents of matter are not point-like particles, but one-dimensional strings, whose vibrations encode the characteristics of particles, forces, and the geometry of space itself. And these strings require additional dimensions for consistency, suggesting that the universe is far more intricate and multidimensional than our immediate perceptions reveal. And as we consider black holes, these extreme objects become natural laboratories for hyperspace, as the immense curvature of space-time and the concentration of mass reveal interactions between strings and dimensions that challenge classical intuition. And even the information paradox, which questions whether information is lost in black holes, may find resolution through higher dimensions, implying that the universe possesses mechanisms to encode and preserve information in ways invisible in three-dimensional space. And as we reflect on the early universe, the Big Bang, and the period of cosmic inflation, hyperspace provides insight into how the distribution of matter and energy, the formation of galaxies, clusters, and superclusters, and the emergence of large-scale cosmic structure were shaped, and every quantum fluctuation, every particle, and every photon participates in this multidimensional interplay, revealing patterns, symmetries, and connections that underlie the observable cosmos. And as we contemplate these principles, it becomes clear that imagination, mathematics, and observation converge for theoretical constructs like higher dimensions, parallel universes, and wormholes are not merely abstract speculation, but consequences rigorously derived from equations that govern the universe. And in exploring these ideas, we are invited to consider not only the physical laws, but the philosophical and conceptual implications. For if countless realities exist, our notions of identity, choice, and destiny take on entirely new dimensions, and consciousness itself may interact with hyperspace in ways we are only beginning to fathom, suggesting that our perception of reality is intimately tied to the multidimensional architecture of existence. And these insights have profound implications for understanding quantum mechanics, cosmology, black holes, galaxy formation, and the ultimate fate of the universe. And as we continue to explore, we recognize that hyperspace is not a distant abstraction, but a unifying framework connecting the microcosm and macrocosm, from subatomic strings to superclusters, revealing a cosmos of astonishing elegance, coherence, and complexity. And through this exploration, we gain a sense of awe, realizing that the universe is far richer, stranger, and more interconnected than our ordinary experience suggests, and that the pursuit of understanding hyperspace is not merely an academic endeavor, but a human journey, a quest to expand our minds, challenge assumptions, and glimpse the extraordinary architecture of reality, where every particle, every wave, and every energy fluctuation participates in a grand multidimensional symphony, a continuous cosmic dance in which the universe itself is the orchestra, the music and the stage. And as we immerse ourselves in this vision, we begin to appreciate the profound beauty, subtlety, and depth of the cosmos, a universe far more magnificent, mysterious, and extraordinary than our senses alone can ever perceive. As we continue to explore hyperspace, we must consider how these higher dimensions influence not only the cosmos at large, but also the very nature of matter, energy, and the forces that govern their interactions. For when we examine the fundamental forces, gravity, electromagnetism, and the strong and weak nuclear interactions, we see that their behaviors may be a direct consequence of the structure of higher dimensional space. And this realization transforms our understanding of why the universe behaves as it does, suggesting that the apparent strengths and weaknesses of these forces, the distribution of matter, and even the formation of galaxies and stars, are not arbitrary, but emerge naturally from the geometry of hidden dimensions. And when we contemplate the concept of parallel universes within this framework, the implications become even more profound. For every quantum fluctuation, every particle interaction, and every choice made in our observable universe may correspond to the creation of alternate realities, each evolving according to its own initial conditions and physical laws, some nearly identical to ours, others radically different. And in this multiverse, causality, probability, and even the nature of identity are profoundly altered, challenging our classical notions of time, space, and determinism. And as we examine time through the lens of hyperspace, we see that it is not a linear continuum, but a dimension that can stretch, loop, and intertwine with space itself, bending in response to gravitational fields and motion. And in this context, wormholes appear as natural solutions to Einstein's equations, tunnels through space-time that may connect distant regions or entirely separate universes, allowing instantaneous traversal that would be impossible within conventional three-dimensional space. And although practical construction of traversable wormholes remains speculative, The mathematical foundation demonstrates their feasibility given the presence of exotic matter with negative energy density. And this illustrates a broader truth. The universe operates according to principles that transcend human intuition. And through the study of hyperspace, we glimpse the underlying order and elegance that governs existence. And string theory further illuminates this reality by proposing that all particles are not point-like, but are instead one-dimensional strings vibrating within hidden dimensions, each vibration determining the particle's properties, interactions, and role in the cosmos. And these strings unify matter and forces, revealing a coherent framework in which the fundamental constants and behaviors of nature are natural outcomes of higher dimensional geometry. And when we consider black holes, these extreme regions provide a natural laboratory for understanding hyperspace, as the immense curvature of space-time and concentration of matter expose interactions that are otherwise invisible. And the information paradox, which asks how information behaves when consumed by black holes, may find resolution through higher dimensional encoding, suggesting that the universe preserves information in ways that transcend our three-dimensional perception. And as we look back to the origins of the universe, the Big Bang and the subsequent inflationary expansion illustrate how the hidden dimensions shaped the early cosmos, influencing the distribution of energy, matter, and the large-scale structures that populate galaxies and clusters. And every quantum fluctuation and particle interaction participates in this multidimensional tapestry, reflecting a deep and elegant order. And as we explore these phenomena, we find that imagination, mathematics, and observation converge. For the theoretical constructs of higher dimensions, parallel universes, and wormholes are not mere abstractions, but necessary consequences of the laws of physics, rigorously derived from the equations that govern reality. And contemplating these ideas invites profound philosophical reflection. For if infinite realities coexist, then concepts of self, identity, and choice take on entirely new dimensions. And consciousness itself may interact with hyperspace in ways that are only beginning to be understood, suggesting that human perception is intertwined with the multidimensional structure of the cosmos. And these insights have sweeping implications, influencing quantum mechanics, cosmology, black hole physics, galaxy formation, and the ultimate fate of the universe. And as we journey further into hyperspace, it becomes evident that this framework unites the microcosm and the macrocosm, from vibrating strings to galactic superclusters, revealing patterns, symmetries, and connections that point to a cosmos of staggering coherence, elegance, and complexity. And through this exploration, we gain awe and perspective, realizing that reality is far stranger, richer, and more interconnected than ordinary experience suggests. And the pursuit of hyperspace is not merely scientific, but profoundly human. A quest to expand understanding, challenge assumptions, and glimpse the extraordinary architecture of the universe, where every particle, every vibration, and every energy fluctuation participates in a multidimensional symphony, a continuous cosmic dance in which the universe itself is the orchestra, the music, and the stage. And as we reflect on these revelations, we begin to appreciate the beauty, subtlety, and depth of a reality that is more magnificent, more mysterious, and more extraordinary than our senses could ever convey. A universe whose hidden dimensions await our discovery, interpretation, and wonder. As we continue to explore the extraordinary landscape of hyperspace, it becomes increasingly evident that the universe is not merely a three-dimensional space with linear time, but a vast, interconnected multidimensional structure in which every particle, every wave, every fluctuation of energy is embedded within a complex network of hidden dimensions. And these dimensions, curled up at scales far smaller than atoms, exert profound influence on the behavior of matter, the propagation of forces, and the very architecture of reality itself. And when we extend our thinking to the concept of parallel universes, the scope of this vision becomes staggering. For every quantum fluctuation, every particle interaction, and every choice has the potential to generate alternate realities, creating a multiverse where countless versions of existence coexist simultaneously. Some nearly identical to our own, others radically different. And in this context, the classical notions of causality, probability, and identity are profoundly transformed as reality becomes a branching, dynamic web in which every possibility is realized somewhere, and time, far from being a linear progression, becomes flexible, influenced by the curvature of space, the presence of mass, and the interplay of higher dimensions. And in this framework, wormholes appear as natural consequences of the equations of general relativity. Tunnels through space-time that may connect distant points, or even entirely separate universes, offering a means of instantaneous travel that defies conventional intuition. And while traversable wormholes remain a theoretical challenge, their consistency within the laws of physics, contingent on exotic matter with negative energy, demonstrates that the cosmos is governed by principles that transcend ordinary experience. And string theory provides further insight, proposing that all matter consists not of point-like particles, but one-dimensional strings whose vibrations determine particle properties, interactions, and the very geometry of space. And these strings exist within the hidden dimensions, unifying forces and matter under a single elegant framework. And as we examine black holes, we find these extreme objects serve as natural laboratories for probing hyperspace, as the immense curvature of space-time and concentration of matter reveal interactions among strings and dimensions that are otherwise hidden. And the information paradox, which challenges whether information is lost within black holes, may find resolution in higher dimensional encoding, suggesting that the universe preserves information in ways invisible to our three-dimensional perspective. And as we reflect upon the early universe, the Big Bang and the subsequent inflationary expansion highlight the role of hidden dimensions in shaping the distribution of matter, energy, and cosmic structure. And every quantum fluctuation, every particle, and every photon participates in this multidimensional dance, reflecting a deep underlying order. And as we study these phenomena, we see that imagination, mathematics, and observation converge. For theoretical constructs such as hyperspace, parallel universes, and wormholes are not mere abstractions, but rigorously derived consequences of the laws of physics. And contemplating these concepts inspires profound philosophical reflection. For if infinite realities coexist, then identity, choice, and the concept of self must be reconsidered, and consciousness itself may interact with these dimensions in ways we are only beginning to comprehend, suggesting that human perception is fundamentally linked to the multidimensional structure of the universe. And these insights have profound implications across quantum mechanics, cosmology, black hole physics, galaxy formation, and the ultimate fate of the cosmos. And as we delve further into hyperspace, we recognize that this framework unites the microcosm and the macrocosm, from vibrating strings to galactic superclusters, revealing patterns, symmetries, and connections that illuminate the elegance, coherence, and complexity of existence. And through this continuous exploration, we are inspired by awe, recognizing that reality is far stranger, more intricate, and more interconnected than ordinary perception suggests. And the pursuit of understanding hyperspace is not merely an academic endeavor, but a profoundly human quest, an exploration of our place within the vast architecture of reality, where every particle, every vibration, every fluctuation of energy participates in a multidimensional symphony, a continuous cosmic dance in which the universe itself is both orchestra and music, stage and performance. And as we contemplate these revelations, we begin to fully appreciate the beauty, subtlety, and depth of a cosmos whose hidden dimensions, intricate patterns, and infinite possibilities are waiting to be discovered, explored, and understood. And in this journey, the human mind becomes both a witness and a participant, capable of glimpsing the extraordinary architecture of reality that extends far beyond the familiar dimensions of space and time, inviting us to expand our understanding, challenge our assumptions, and immerse ourselves in the magnificent, mysterious, and awe-inspiring universe that hyperspace reveals. As we proceed further into the exploration of hyperspace, it becomes increasingly apparent that the universe is not merely a three-dimensional expanse punctuated by matter and events, but a profoundly interconnected, multidimensional tapestry in which every particle, wave, and fluctuation of energy participates in a continuous, intricate cosmic dance. And when we examine the hidden dimensions proposed by string theory, we realize that these dimensions, curled up at scales far smaller than atoms, are not theoretical abstractions, but fundamental elements that shape the behavior of forces, the properties of particles, and the very structure of space-time itself. And as we extend our vision to parallel universes, The scope of possibility becomes staggering. For every quantum fluctuation, every particle interaction, and every choice made within our universe may give rise to alternate realities, forming a multiverse where countless versions of existence coexist simultaneously. Some nearly identical to our own, others radically divergent. And in this multiverse, classical notions of causality, probability, and identity are profoundly transformed as reality branches dynamically, giving rise to infinite potentialities and time. Far from being a linear progression, becomes flexible, influenced by the curvature of space, the distribution of mass, and the geometry of hidden dimensions. And within this framework, wormholes emerge as mathematically natural constructs, hypothetical tunnels through space-time that may connect distant points or even entirely separate universes, potentially allowing instantaneous traversal across unimaginable distances or realities. And while constructing a traversable wormhole remains a monumental technological challenge, the mathematics validates their possibility, contingent upon the existence of exotic matter with negative energy. And this demonstrates a deeper principle. The universe is governed by precise, elegant laws that often transcend ordinary human intuition. And string theory further illuminates the picture, proposing that all matter consists of one-dimensional strings, whose vibrations encode the properties of particles, forces, and the geometry of space, and these strings exist within hidden dimensions, unifying matter and forces under a coherent, elegant framework. And as we explore black holes, these extreme objects reveal the principles of hyperspace in action. For the immense curvature of space-time and the concentration of matter expose interactions among strings and dimensions that are invisible under ordinary conditions, and even the information paradox, which questions whether information is destroyed when consumed by black holes, may find resolution through higher dimensional encoding, suggesting that the universe preserves information in ways imperceptible in three-dimensional space. And reflecting on the early universe, the Big Bang and the inflationary expansion illustrate the role of hidden dimensions in shaping cosmic structure, influencing the distribution of matter and energy, and orchestrating the formation of galaxies, clusters, and voids, and every quantum fluctuation. Every particle and every photon participates in this multidimensional interplay, revealing an underlying order that governs the cosmos. And as we study these phenomena, imagination, mathematics, and observation converge. For concepts like hyperspace, parallel universes, and wormholes are not mere abstractions, but rigorously derived consequences of fundamental physical laws. And contemplating these ideas encourages philosophical reflection. For if infinite realities coexist, then identity, choice, and the self take on new meanings, and consciousness itself may interact with these dimensions in ways only beginning to be understood, suggesting that perception and reality are deeply intertwined. And these insights resonate across quantum mechanics, cosmology, black hole physics, galaxy formation, and the ultimate fate of the universe. And as we continue to explore hyperspace, we recognize that this framework unites the microcosm and macrocosm, from vibrating strings to galactic superclusters, revealing patterns, symmetries, and connections that speak to the elegance, coherence, and complexity of existence. And through this exploration, we are filled with awe, realizing that reality is far richer, stranger, and more interconnected than ordinary perception suggests. And the pursuit of hyperspace is not merely scientific, but profoundly human, a quest to expand understanding, challenge assumptions, and glimpse the extraordinary architecture of reality, where every particle, every vibration, every energy fluctuation participates in a multidimensional symphony, a continuous cosmic dance in which the universe itself is orchestra, music, and stage simultaneously. And as we immerse ourselves in this vision, we begin to appreciate the profound beauty, subtlety, and depth of a cosmos whose hidden dimensions, intricate patterns, and infinite possibilities are waiting to be discovered, explored, and understood, inviting the human mind to engage fully with the magnificent, mysterious, and awe-inspiring reality that hyperspace reveals. A reality in which imagination, mathematics, observation, and consciousness converge, providing insight into both the universe and our place within it, and offering a continuous journey of discovery, wonder, and understanding that stretches far beyond the limits of perception and comprehension, revealing the extraordinary, multidimensional, and elegant nature of existence in its entirety. As we reach the culmination of our journey through hyperspace, it becomes abundantly clear that the universe is an extraordinary, multi-dimensional entity in which every particle, every wave, and every energy fluctuation participates in a vast, interconnected cosmic network. And when we consider the hidden dimensions proposed by string theory, we understand that these dimensions, although imperceptibly small, shape the very behavior of matter, the propagation of forces, and the structure of space-time itself. And these dimensions provide the scaffolding upon which the cosmos is built, determining why fundamental forces have the strengths they do, why constants are finely tuned for life, and why the universe exhibits both order and diversity on scales ranging from the subatomic to the galactic. And as we extend our imagination to parallel universes, we confront the mind-expanding notion that every quantum event, every particle interaction, and every choice creates a branching of realities, forming an infinite multiverse where countless versions of existence unfold simultaneously, some nearly identical to our own, others radically different. And in this multiverse, time, space, and causality are no longer absolute but flexible, contingent upon the geometry of hidden dimensions, the curvature of space-time, and the distribution of matter and energy, and wormholes, emerging naturally from the equations of general relativity, appear as tunnels that may connect distant regions or entirely separate universes, offering potential pathways for instantaneous travel across unimaginable distances. Although traversable wormholes remain a speculative challenge, their theoretical consistency highlights a profound truth. The universe operates according to precise, elegant laws that often surpass human intuition. And string theory further reveals that all matter is composed of one-dimensional strings whose vibrations encode particle properties, forces, and the geometry of space, existing within the hidden dimensions and unifying the forces of nature into a coherent framework. And as we examine black holes, these extreme objects expose the principles of hyperspace in action. With immense curvature of space-time and concentrated matter revealing interactions between strings and dimensions that are otherwise invisible, and the information paradox, questioning whether information is lost in black holes, may be resolved through higher dimensional encoding, implying that the universe preserves information in ways imperceptible within three-dimensional space, and reflecting on the early universe. The Big Bang and inflation demonstrate how hidden dimensions influence the distribution of matter and energy, orchestrating the formation of galaxies, clusters, and cosmic structures. And every particle, every photon, every quantum fluctuation participates in this multi-dimensional symphony, revealing a deep, elegant order underlying the cosmos. And as we explore these phenomena, imagination, mathematics, and observation converge. For concepts such as hyperspace, parallel universes, and wormholes are not abstract ideas, but rigorously derived consequences of physical laws. And contemplating these ideas inspires philosophical reflection. For if infinite realities coexist, notions of self, identity, and choice are transformed, and consciousness itself may interact with these dimensions in ways only beginning to be understood, linking perception with the multidimensional structure of reality. And these insights resonate across quantum mechanics, cosmology, black hole physics, galaxy formation, and the ultimate fate of the universe. And as we push the boundaries of knowledge, hyperspace unites the microcosm and macrocosm, from vibrating strings to galactic superclusters, revealing patterns, symmetries, and connections that illuminate the elegance, coherence, and complexity of existence. And through this journey, we gain awe, realizing that reality is far stranger, more intricate, and more interconnected than everyday experience suggests. And the pursuit of understanding hyperspace is not merely a scientific endeavor, but a profoundly human quest, a continuous journey to expand understanding, challenge assumptions, and glimpse the extraordinary architecture of reality, where every particle, every vibration, every energy fluctuation participates in a multidimensional symphony, a continuous cosmic dance in which the universe itself is orchestra, music, and stage simultaneously. And as we reflect on these revelations, we fully appreciate the beauty, subtlety, and depth of a cosmos whose hidden dimensions, intricate patterns, and infinite possibilities are waiting to be discovered, explored, and understood, inviting the human mind to engage with the magnificent, mysterious, and awe-inspiring universe that hyperspace reveals. A universe in which imagination, mathematics, observation, and consciousness converge, offering insight into the cosmos and our place within it. A universe that continuously challenges us, inspires us, and reveals, in the most profound ways, the hidden truths that lie just beyond perception, guiding us on an endless journey of discovery, understanding, and wonder through the extraordinary, multidimensional, and elegant nature of existence itself. Just as the cosmos is vast, mysterious, and full of hidden dimensions, so too is life. Every challenge, every choice, every moment is part of a greater tapestry we may not yet see. Embrace curiosity, stay open to possibilities, and remember that even the smallest actions can ripple across time and space, shaping a universe far larger than yourself.